This
So
conference will now be recorded.
protic solvents means the solvent which contain an hydrogen. That is, hydrogen is attached to oxygen through the hydrogen bonds. Example for protic solvents, we have water, alcohol like methanol, ethanol. They are called as protic solvents because these solvents contain hydrogen which is attached to oxygen through hydrogen bonds.
Even acids, no ma'am, they are also protic solvents.
They are
I mean,
also
no,
protic
alcohols
solvents.
are alcohols also.
Yes, I said no, water and alcohols.
Yes, ma'am.
Most of the proton, that is hydrogen containing compounds, are protic. And hydrogen which is attached to oxygen through hydrogen bonds, especially, they are also termed as protic solvents. So here the solvent anions are attached to hydrogens through hydrogen bond. So I gave the example right here. So the hydrogen is going to form a hydrogen bond with the solute which is having a anion. Similarly, cations are attracted towards negative pole. So in case of water, negative pole is oxygen because it has unshared pair of electrons. And anions are attracted towards positive pole of the polar molecules. In case of water, the positive pole is, which is the positive pole. In case of water, the positive pole is hydrogen. The ion dipole bond holding anions to water is known as hydrogen bond. So other protic solvents solvate ions in the same manner that water, how it does similarly. Cations through unshared pairs, anions through hydrogen bonding. Next is aprotic solvent. So aprotic solvents means these are the with moderately arranged dielectric constants and they don't contain acidic hydrogen. They contain hydrogen but it is not acidic. Examples are, what do you mean by DMSO, DMF and HMPT? DMSO means dimethyl sulfoxide. DMF means dimethyl formamide. HMPT means hexamethyl phosphotriamide. So these are the examples of aprotic solvents. So the aprotic solvents dissolve ionic
Ma'am,
compounds.
excuse me, ma'am.
Yes,
Ma'am, toluene also can be an example, right?
toluene is an example of,
Aprotic, ma'am.
yes, aprotic, where it does not contain an acidic hydrogen.
Okay.
So the aprotic solvents is going to dissolve ionic compounds, but they cannot form the hydrogen bond to anions. How the protic solvents is going to form? It's not going to form here. So aprotic solvents are highly polar and thus they can dissolve ionic compounds through the solvation of cations. So these are the structure of DMF and DMSO. You can see N, N dimethyl formamide is nothing but DMF and dimethyl sulfoxide is DMSO. So the oxygen has a partial negative charge which is on the surface of the molecule. And in DMSO also the oxygen is partially negative charge which is on the surface of the molecule. Whereas the carbon and sulfur, they have the partial positive charge. They are not very easily accessible as compared to the oxygen atom because they are little inside. So DMSO can solvate a cation better than it can solvate an anion. Why? Because the oxygen atoms are on the surface and they possess a partial negative charge, so they can attract the cations like potassium ions or any cations, and they can solve it easily. So where does this great amount of energy comes from for solubility? The amount of energy comes from formation of the many bonds, the bonds between the ions produced and solvents, between ions and solvents. The ions are not generated as naked particles, but they are generated as solvated ions. So you can see here, ions are nothing but the products of heterolysis. I'll discuss about this heterolysis and homolysis in the next class. So hetero means, what do you mean by hetero and homo? Homo means same, hetero means
Combination
different.
of
Hetero means different. Lysis means breaking. So when the bond is breakdown in unsymmetrical, it is not symmetrical, unsymmetrical or differently, the products obtained are ions, that is the charged particles. So individually, each of these ion dipole bonds is relatively weak, but altogether if you take, they provide great deal of energy. So the reactant has dipole moment and forms dipole-dipole bonds to solvent molecules. If you take an example, what is Rx? Rx is alkyl halide. So alkyl halide, during the transition state, how the bond is getting break, you can see. So R is alkyl, X is halogen. Halogens are negatively charged, whereas alkyls, CH3 is positively charged. So when they are breaking down, the R group will possess a positive charge, whereas the halogens will possess a negative charge. So this is how the ions are formed. So this is in case of reactions. And we can also classify the solvent in 3 ways. That is molecular structure of solvents, inorganic solvents, and organic solvents. So molecular structure of solvents means the ability of a substance to dissolve another substance is determined by compatibility of their molecular structures. So based on molecular structures, how they are going to dissolve. So that is classified as molecular structure of solvents. The concept here is like dissolves like. So under molecular structure, the solvents are again classified as polar protic solvents, dipolar aprotic solvent, and non-polar solvent. These are the 3 types. First one is polar protic solvent. Polar protic solvent molecules consist of a polar hydroxyl group and a non-polar tail. So the structure may be represented by the formula ROH, where R is alkyl and OH is polar hydroxyl group. So polar protic solvents dissolve other substance with polar protic molecular structures. The substance should have this polar protic molecular structure, then only it can dissolve. Polar protic solvents are miscible with water. Examples of polar protic solvents are like water, acetic acid, methanol, ethanol, N-propanol, and butanol. All the alcohols comes under polar protic solvents. And dipolar aprotic solvents, we have a molecule possesses a large bond dipole moment. They do not contain OH group. Examples of dipolar aprotic solvents, we have acetone, ethyl acetate, DMSO, acetonitrile, and DMF. So these comes under dipolar aprotic solvents. Next is non-polar solvents. So these are electric charge in the molecules of non-polar solvents is evenly distributed. So they have very low dielectric constants. So these non-polar solvents are hydrophobic. So they are not miscible with water. They are immiscible with water. Non-polar solvents are lipophilic as they dissolve non-polar substances like oils, fats, greases. They can also be solubilized using this non-polar solvents. Examples for non-polar solvents are carbon tetrachloride, benzene, diethyl ether, hexane, and methylene chloride or dichloromethane. Next is inorganic solvents. So the most popular inorganic solvent is water and aqueous solutions which contains a special additives like surfactants, detergents, pH buffers, inhibitors. So if they contain, they are called as inorganic solvents. The other inorganic solvents are examples like liquid anhydrous ammonia, concentrated sulfuric acid, sulfuryl chloride, fluoride. These are the examples of inorganic solvents. And the last is organic solvents. So organic solvents are oxygenated solvent which contain oxygen. Oxygenated solvents are widely used in paints, inks, pharmaceuticals, fragrance sectors, adhesives, cosmetics, detergents, and food industries. Examples of oxygenated solvents are alcohols, glycol, ethers, methyl acetate, ethyl acetate, ketones, esters, glycol ethers, and glycol esters. Next is hydrocarbon solvents. This is also comes under organic solvents. So this consists only of hydrogen and carbon atoms, and they are hydrocarbon solvents. These are produced in form of volatile fractions in refinery of crude oil. So what are the hydrocarbon solvents? We have examples: paraffin, naphthenic, and aromatic constituents in various proportions. So hydrocarbon solvents contain these constituents like paraffinic, naphthenic, and aromatic constituents. What do you mean by paraffinic? Paraffins are nothing but alkanes. Naphthenic means which contain naphthalene. Aromatic means which contain at least benzene ring. So the hydrocarbons contain these constituents. So aliphatic solvents, molecules of aliphatic solvents have straight chain structure. Example: hexane, gasoline, kerosene. White spirits is a mixture of aromatic and paraffinic hydrocarbons. Pure aromatic solvent molecules have benzene ring structure in it. Example: we have benzene, toluene, and xylene. We also have halogenated solvents. So these molecules contain halogenic atoms, either chlorine, fluorine, bromine, or iodine in it. So chlorinated solvents, examples we have trichloroethylene, perchloroethylene or tetrachloroethylene, methylene chloride or dichloromethane, carbon tetrachloride, chloroform, 1,1,1 trichloroethane or methyl chloroform. Fluorocarbon solvents, so which contains fluorine, dichlorofluoromethane, trichlorofluoromethane, tetrafluoromethane, dichloromethane, hydrochlorofluorocarbon. These are the fluorocarbon solvents. Similarly, we have brominated solvents. Example: ethylene dibromide, methylene chlorobromide, and methyl bromine. Next is iodinated solvents. Here we have iodinated solvents, N-butyl iodide, methyl iodide, ethyl iodide, and N-propyl iodide. So these are the different types of solvents. So understood what are the different types of solvents? Either you can classify simply protic and aprotic solvents, or you can also classify it like molecular structure, inorganic and organic solvents. So any doubts? Yes. Can you hear me? Ritika? Yes, Ritika, can you hear me?